Hello students, welcome back. Yes, we are still not done with certs. In this video, we're going to solve some homework questions from exercise 3.2. Right, we're going to solve these questions involving certs. But before that, let's do a recap of all the rules that we have learned. Right, so for A and B more than 0, right, we have learned this. Also this one. And this. Right, so this one will collapse into, okay, square root square of a square root a will gives you a. So we'll be using this one. We'll be using this, right, to solve our equations involving certs. So we're going to square both sides of our equation. All right, so what do we get? Yes, we'll get 2x minus 3 equals to 25. And 2x will be equals to 25 plus 3, that gives you 28, and x equals to 14. Now, the next thing we need to do is that, because when we square equations involving certs, we're actually introducing some answers which may not be valid. So hence, we need to substitute our answer, the values we get for x, into the original equations to check if the answer we get actually satisfy the equation. So how do we do it? Right. So this is how we do it. We need to do a check. All right, so we're going to substitute x equals to 14 into the left-hand side of our equation, which is square root 2 multiplied by 14 minus 3, and that gives you 28 minus 3, which is 25, and square root 25 is 5. And the right-hand side that we are given here is 5. So since the value for left-hand side is equals to the value for right-hand side, we can conclude that therefore x equals to 14 is a valid solution. Alright, so this is how we do it. Right, let's look at 1D. So for this question, we'll be applying the same concept as what we have done earlier. And that is, we're going to square both sides of your equation. Alright, then you will end up with 8 minus x on the left, x minus 2 on the right. Okay, we're going to bring all your x terms together. So negative 2x equals to negative 10, x equals to 5. Alright, we're going to check if our answer x equals to 5, if it's a valid answer. So let's do a check. Alright, so our left hand side will be square root 8 minus 5. That gives me square root 3. And then the right hand side will be square root 5 minus 2 gives you square root 3. And so since the values you get for left hand side is equals to the right hand side, therefore x equals to 5, it's a valid answer. Right, let's look at question 5. So for question 5, if you're going to apply the same concepts as what we've done earlier, um, you may be tempted to do this, right? But to do this, you must remember to apply the algebraic identity, this one. Which will gives you all right, and then you end up having a term involving a radical sign, so where you still have to square, that means you simplify this guy, bring it to the right hand side, and then you have to square both sides again to get rid of your radical sign. So therefore, to avoid having to avoid being what is the word, trapped in this kind of situation, okay, an easier way, let me erase all this first. An easier one will be just, before you apply the concepts of squaring both sides of an equation, we just bring this guy over to the right hand side. All right, so this will appear to be similar to what we have done early on, and then you can just apply the concepts of squaring both sides, okay, and you will get 3x minus 7, and here if you square a negative, this one means it's a negative 1. If you square a negative 1, you will get a positive, and then when you square root 2x minus 1, you will just get 2x minus 1. All right, so let's simplify further. Okay, as usual, we need to check if x equals to 6 is a valid answer. So we're going to substitute into the original equation. Right, so let's check the values for left hand side, which will be square root 3 times 6 minus 7 plus square root 2 times 6 minus 1, and that we'll get 18 minus 7, that's 11. 18 minus 7, that's 11 here, plus 6 times 2, 12, square root 11. Alright, so you will have actually 2 square root 11. Right, but on your right hand side, it's actually 0. So from here, we can conclude that since left hand side is not equal, the value that you get from left hand side is 2 square root 11, right? And 2 square root 11 definitely is not equal to 0. So x equals to 6. It's not a valid answer. So hence, the equation that we're given has no solution. Okay, we managed to find a solution which is x equals to 6, but after substituting x equal to 6 into the original, this is your original equations involving surds. Alright, we find that the values we get on the left hand side It's not equals to the value that is given on the right hand side. So therefore, even though we have this value x equal to 6, this is not a valid answer. It's not a valid solution. Hence, the equation actually has no solution at all. Right, let's look at another type of questions. Okay, in this case here, if you were to examine the equations you're given, we have some rational numbers. A is a rational numbers, and we also have surds square root 2, and also b square root 8. Right, so we can actually start off by doing some expansion. For example, this guy, we can just use your algebraic identity to expand it, and this one we can actually just simplify it. Alright, so first thing first is to use our algebraic identities, which is this one here. I'm sorry, it's a minus b. Alright, to expand this guy, so that will give us minus 2 times 3 times 2 square root 2 plus bracket 2 square root 2 close bracket squared. And this we can simplify it to be square root 4 times square root 2, right? So let's continue to simplify further. That will give us 9, and this will give us 2 times 3, 6 times 2, 12. This one you can easily use a calculator to help you work it out. That will give you 8. 2 squared, 2 times 2, 4. Yeah, 8. And this will give us square root 4 is 2. B times 2 is the same as 2b. So 2b times square root 2 will be just 2b square root 2. Alright, let's simplify further. So that will be 17. And this guy and this guy, we can just put them together. Alright, you can put the positive first. Alright, so we're just going to do some comparison. Alright, so we're just going to compare rational numbers on the left with the rational numbers on the right, and then the surds on the left with the surds on the right. So in this case here, a is equals to 17. Alright, and this guy here, right, will be equals to this guy that I've circled. Alright, so therefore we will have a equals to 17, and then we will have 2b square root 2 minus 12 square root 2 equals to square root 2. So I can factorize square root 2 from my left hand side, and then I can divide by square root 2 on both sides. So I would end up getting 2b minus 12 equals to 1. Okay, square root 2 divided by square root 2 is 1. So 2b will be equals to 13. Therefore, b will be equals to 6.5. Okay, so that's how we do it. Right, let's look at 9b. So the concepts involving here, the concepts involving 9b actually is rather similar to the one we have done earlier. It's just to compare the rational numbers on the left with the rational numbers on the right, and then the surds on the left with the surds on the right. So in this case here, then we will have to use distributive law to expand it. So that will give us 3 times 4 plus a square root 3 minus 2 square root 3 times 4 plus a square root 3. That will be 12 plus 3a square root 3 minus 2 times square root 3 times 4. That will give you 2 times 4 first. That's 8. 8 times square root 3 will be just 8 square root 3. And then be careful, there's a trap there. That will give us minus first. Take care of the sign first, and then take 2 times a. That gives you 2a. And square root 3 times square root 3 gives you 3. Alright, let's simplify further. Alright, so we're going to put all the rational number together. That will be 12 minus 6a, and then your desserts together. Okay, and then we're going to do a comparison. So this guy, 12 minus 6a, it's a rational number, will be equals to b, which is a rational number. Basically, rational numbers, you just don't have the radical, you don't have the surds there. So the surds will be this guy here, where you have the square root 3 one, and then with the square root 3. Okay, so we can form two equations. So the first equations will be 12 minus 6a is equals to b. Alright, we're going to call this equation 1. And then the second one will be 3a square root 3 minus 8 square root 3 equals to negative 23 square root 3. So we can factorize our square root 3 on the left hand side. Alright, you can divide by square root 3 on both sides. That will end up getting 3a minus 8 equals to negative 33. We're going to call this equation 2. Right. Wait. Am I missing something? Oh no. Right, so actually we don't need to call this equation 2. We can just go ahead and solve for the letter a. So 3a will be equals to negative 23 plus 8, which will get negative how many? 3, 4, 5, 6, 7, 8, 15. So 3a is equals to negative 15. A will be negative 15 divided by 3. That gives you negative 5. Okay, so having found the values of a, we can just substitute it into your equation 1. So we're going to substitute a equals to negative 5 into equation 1. And we'll get 12 minus 6 times negative 5 equals to b. So b will be 12 plus 30 gives you 42. Alright, that's how we solve for the values of a and b. Relatively easy. Right, so this is another type of questions that you may encounter. Right, but you will see that the concepts are more or less the same. Right, basically you just have to compare rational numbers on the left with the rational numbers on the right, surds on the left with surds on the right. That is the concepts that we'll be using throughout, that we have been using throughout, and we'll be using it again. Alright, so here we're going to form equations. You are given the equations already, so we're going to make do some manipulations, right, to make it equations that we've seen earlier. The equations we have seen earlier will be like something equals to something, right? No fractions involved. So we want to get rid of this fraction, this guy here. So to get rid of these fractions, I'm just going to multiply with the denominator, which is a plus b square root 7. So this multiply with a plus b square root 7. Alright, so then I will end up getting 2 plus 4 square root 7 on my left hand side. And this one here, we're going to use distributive law to expand it. Alright, so square root 7 times a will be a square root 7. Okay, there's a catch here, so be careful. That will give you negative. So square root 7 times b times another square root 7. That will give you square root 7 times square root 7 will be 7. So 7 times b will be 7b. Right, let's simplify further. I'm going to put all the rational numbers together, which is 4a minus 7b. And then put the surds together. Alright, so we're going to do some comparison. Right, so we compare rational number with rational number, and then the surds with surds. Alright, so we will be getting two equations, and I think we need to solve them simultaneously. So the first equation would be 4a minus 7b equals to 2. Okay, we're just going to leave it as like this, call it equation 1. The second one to be 4b square root 7 minus a square root 7 equals to 4 square root 7. Can factorize your square root 7 on the left hand side. Divide by square root 7, you will have 4b minus a equals to 4. Oh, good. So I'm going to make a the subject. So I would have 4b minus 4 equals to a. Call this equation 2. So I'm just going to substitute 2 into 1. So I would get 4 bracket 4b minus 4 minus 7b equals to 2. That will give me 16b minus 16 minus 7b equals to 2. 16b minus 7b, that will give me 9b. 2 plus 16 will give me 18. So b will be 18 divided by 9 and give me 2. So after finding the values for b, we're just going to substitute b equals to 2 into equation 2. So therefore a will just be 4 times 2 minus 4. That will give me 8 minus 4 equals to 4. Alright, so you see that there are many ways that they can actually different kind of questions, different ways of asking you, but the concepts involved are the same, right? The concepts involved are the same. Basically, you just compare rational numbers on the left with the rational numbers on the right, sets on the left with sets on the right. That's it. Right, so let's look at these questions. So if you're going to use the same concepts of what we have done earlier, right, we will have to square both sides. And let me tell you what happens if you do that. Okay, the right hand side is pretty easy. When you square a square root, the radical sign will be gone. That's exactly what you want. And then this guy here, okay, you may not want to expand it, because if you're going to expand it using your algebraic identity, right, you end up getting, okay, let me do it, and then you will see how complicated it will become. You end up getting x to the power 4 minus 4x cubed plus 4x squared equals 2x squared minus 4x plus 3. And then you end up getting rather complicated equations with x to the power 4. Right. So when you have something like that, then you will realize that maybe this is not the correct way or the efficient way to solve it. So maybe I need to, not maybe, but I really need to relook, okay? Relook, go back and look at the questions and then see if we can find any patterns there. See if you can find anything that I can simplify, anything that, you know what I mean? Like anything that's similar, compare the left with the right and see if there's anything that is similar that you can use, right? So I discovered something. What is it that I discovered? I discovered this, that is you see, if I were to factorize 2, that means I concentrate on these two terms, factorize 2 out, I basically, do you see what I see? Can you see that this guy is similar to this, right? So what I'm going to do is that I'm going to make things easier by replacing x squared minus 2x with the letter a. Okay, right. So this is also one of the remember the Poyer's 4 steps problem solving skill. One of them is to restate the problem. So this is what we are doing. We are restating the problem. So I'm going to replace x squared minus 2x with the letter a. So I would have a equals to square root 2a plus 3. So now I can square both sides to get 2a plus 3 equals to a squared. Right, square both sides. I would have a squared equals to 2a plus 3. And if I were to bring everything to the left hand side, can you see now it's manageable because it involves a quadratic equation rather than one that we had just now. Right. So I can actually just factorize the quadratic equation easily. All right, and then I will have a equals to -1 or a equals to 3, right? Okay, so do remember that a is just a substituted values for x squared minus 2x. Right, so I need to replace the a back with my x squared minus 2x. Right, so when a is equals to -1, what we have will be x squared minus 2x equals to -1, x squared minus 2x plus 1 equals to 0. Factorize further, you will get this, and you have x equals to 1 as one answer. And then when a equals to 3, you will have x squared minus 2x equals to 3, x squared minus 2x minus 3 equals to 0. Factorize it. You have x equals to 3 or x equals to -1. Right, but however, not all the answers are valid. Remember, we need to check for the validity. Validity, yes. So what we need to do is we have to substitute the values of x equals to 1, x equals to 3, x equals to -1 into your original equation. The original equations refer to this guy. This is your original equation. This one here. Okay, so we need to substitute that. So we're going to do it with x equals to 1 first. Right, so we're going to do the check here. Right, so when x equals to 1, right, so our left hand side will be, just use your calculator to help you, 1 squared minus 2 times 1, so that will gives you -1. Right hand side will be square root, so that will be square root of 2 minus 4 plus 3, so that gives you square root 1. That, oh, so we see the left hand side it's not equals to right hand side, so therefore x equals to 1 is not valid, or we can say it's rejected or not valid. Okay, so x equals to 1 is rejected. All right, then let's go on to x equals to 3. So when x is equals to 3, do the same for your left hand side, which you will get 9 minus 6, that gives you 3. Right hand side, oh, just now was left hand side, sorry. Right hand side will be square root 2 times 9, 18. 18 minus 12, 6. 6 plus 3 is 9. Square root 9. Oh, very good. I have left hand side equals to right hand side. So therefore, x equals to 3. It's a valid answer. It's a valid answer. And finally, we have to do for x equals to -1. Alright, apologize for the presentation. So, but when you do your homework, you just write it properly. Here my screen is too small. Okay, so when x equals to 1, okay, likewise do for the substitute into left hand side, which is just 1 plus 2, that gives you 3. Then your right hand side will be square root 2 plus 4 plus 3. Yeah, give you 3. Okay, so therefore x equals to -1 is also a valid answer. So therefore, there are two answers here, x equals to 3 and x equals to -1, and we have to reject x equals to 1. Alright, so the concept involving here, the skill involved here is that if you cannot solve a very difficult questions, what we can do is you can use restate the problem and use substitution. Substitution is a very useful method to solve quite a lot of problems. Right, so let's come to the last questions of your exercise 3.2. Okay, so it kind of looks complicated. Ayo, there's two radical sign there. Explain why the equations blah 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 has no real roots. So I suppose what they're trying to say is that you just go ahead, find the values of x, and then show that this value of x it's not valid lah. That means you go ahead, do as per normal, solve it, find the values of x, and then when you substitute this value of x into the original equation, you just find that left hand side is not equals to right hand side, so therefore the equations has no real roots. Okay, so how do we go about doing it? I think I'm not keen to square both sides on the left. Maybe, how about if I do like that, would it be easier? And then square it. Okay, so the left hand side is pretty easy. Then the right hand side will be a bit difficult. You have to apply your a minus b squared. I think this question is not difficult lah, it's just tedious. You know what I mean? Algebraic challenging lor. Okay, there's a trap here. You make sure you bracket it. Okay. Alright, simplify further. Alright, I'm going to bring everything to the left hand side, leaving only this guy on the right hand side because I need to apply squaring both sides again. So I would have x squared plus 3x plus 7 minus 4 minus x squared minus 3x plus 9 gives you negative 4 square root x squared plus 3x minus 9. Okay, so this and this goes off. This and this goes off. Oh, happiness, a lot of things goes off. 7 minus 4 will be 3. 3 plus 9 will be 12. Alright, simplify further. You can divide both sides of the equations by 4. That will give me 3 negative. Alright, and then I need to apply square of squaring both sides again. So I would end up getting 9. And then when you square a negative 1, you get positive 1. Square is square root. So you end up getting x squared plus 3x minus 9. Bring everything to the to one side. Alright, factorize it. So x is equals to negative 6 or x equals to 3. Okay, so we have two answers here, x equals to negative 6 or x equals to 3. So as usual, right, they may not be the answer. So what we need to do is we have to substitute both values into your original equation. Okay, so I'm going to do it here. Okay, so this little portion here, I'm going to dedicate it to do my checking. So check. Right, so when x is equals to negative 6, my left hand side will be, just use a calculator to help you, okay? That will be 36. Oh, I don't have a calculator. But you do have a calculator, right? So you just use a calculator to help you lah. That will give me 36 minus 18, that's 18. 18 plus 7 is 25. Square root 25, that give me 5. Then right hand side will be square root negative 36 square root 36 minus 18 minus 9. So that will be 18 minus 9. That's 9. Square root 9 is 3. 5 plus, oh no, this is also left hand side. Oh my goodness, they are both left hand side. So that means what we are having is we are both left hand sides add up to be 5 plus 3 equals to 8. And then your right hand side you're given it's 2. So since left hand side is not equals to right hand side, x equals to negative 6 is rejected. Alright, so you do the same for x equals to 3. Okay, so I'm going to delegate. Okay, really running out of space, my goodness. Dedicate this little spacer for x equals to 3. So when x is equals to 3, alright, do the same for the left hand side. Ayo, so that will give me square root. I need to do some mental calculations. Okay, 3 squared, that's 9. 9 plus 9, 18. 18 plus 7, 25. Then plus another 9. 9 plus 9, 18. 18, 9. So that will give me 5 plus 3, 8. Oh, so again, you see that the right hand side is 2. Right. So therefore, we can see very clearly that left hand side is not equals to right hand side. Okay, you can conclude it on your own. I have no more space there really. You can conclude that since left hand side is not equals to right hand side, because obviously 8 is not equals to 2, x equals to 3 is not valid, is rejected. So both answers we found are both not valid. Okay, so hence the equation has no real roots. So you can do a conclusion here. You can do a conclusion. I'm going to dedicate this little space to do the conclusion. So since x equals to negative 6 and x equals to 3 are rejected, therefore the equation has no real roots. Alright, so this question is not exactly difficult, but it's just algebraically challenging because you have to do squaring both 2 times. And after doing it, you still have to do some check on your answers. And then we discovered that both answers does not satisfy the equations given. So therefore, this particular equation has no real roots. Alright, so that ends the videos. Alright, okay. Alright, thank you.